you don't need to have all the answers, Stacey. But it's good. I mean, like I said, my job is getting people to talk about it. So we're here, we're talking about salt. All right, it's showing up on one screen and I see it on the other. So we are set.
Technology is our friend today.
Sorry, what?
Technology is our friend today.
Technology is our friend. Yeah, not always, but we'll take it. We'll take it. A fickle friend. All right. Well, hello everybody who's joining in right now. Thank you so much for joining the live stream. It's really fun to have folks in the audience. So we really appreciate your questions and comments. And you can always type those into the chat. That's the easiest way on my end. If it doesn't work on your end, you can email me, wisaltwise@gmail.com, and I will put that into the chat for reference. So I should probably introduce myself. I'm Allison Madison, program manager at Wisconsin Saltwise, and I work to host monthly webinars like this, where we can really dive into some of the relevant topics surrounding winter maintenance. Today, focusing right in at some of the materials, the products that are out there. Next month, we'll be looking at calibration of trucks. So one of the most important things, and I think Stacey's going to touch on that a little bit with kind of smaller scale today, but next month we'll be calibrating bigger trucks, used streets and roads. And then, yeah, we'll go from there. So thanks again for joining in. And with that, I'm going to turn over to my lovely colleague here, Stacey, who has been just very dedicated to this issue of educating people to use de-icers appropriately. And so I'm excited for her presentation today.
Thank you, Allison. I'm very excited to be here. For those of you who are unfamiliar with Reinders, I'm with Reinders. We are one of the larger Midwest distributors of products to the commercial green industry, and that's since 1866. I've only been there for 4 years, so don't worry, I'm not that much older than dirt. We have 14 stores and warehouses in Minnesota, Wisconsin, Illinois, Kansas, and Michigan. Our corporate office is in Sussex, Wisconsin. Our specialties are Toro and vent track equipment, irrigation, fertilizer, grass seed, landscape lighting, power equipment, hand tools, holiday lighting, and then of course, snow and ice control. And we do conduct numerous annual trainings in all these specialties for our customers and employees alike. And then our customers rely on us to have that quality product and when they need it. And then also rely on us to have the expertise to help them make their choices. So we do strive to be proactively aware of and ready for shifts in industry standards, thus this presentation today. So what I talk about today is intended to help you make informed decisions about your ice melt choices, and in return, your choices will help you to reduce your winter chloride usage while keeping your surfaces safe for human travel. I'm going to make an assumption here that most of you know that too much of anything is not a good thing, and that includes the ice melters that we use to keep that winter precipitation from sticking to the paved surfaces. And to further set the groundwork so we're all on the same page, chlorides refer to the primary winter salts we use, and those are shown in this chart of by popular use and relative cost. So that's sodium, calcium, magnesium, potassium. And a couple other things about this chart. The effective temperature refers to the lowest temperature in which these can get to work quickly. And then,
Stacey, I need to interrupt for a second. We don't see your chart right now. So your slides aren't up if you want to share your screen.
They're not?
No.
Because you should. Oops.
Do you want to go down to share screen at the bottom? I think maybe that one step needs to happen.
Oh, that's probably it.
Yeah.
Hang on a minute here. Let me get back into it. Oh, wait. Yes. There you go.
Perfect.
All right, now you see it. So what I was saying in this chart, you have, if you look a little bit farther over towards the right there, you've got the effective temperature. That's what I was referring to as those are temperatures that are where they can get to work really quickly. And typically the eutectic temperature is that temperature that is the very lowest at which it will freeze. So we're interested in effective because we all want these things to work fast. The environmental impacts, so we can easily see that in the spring when there's too much fluoride getting into the soil and it's killing the turf and plants. But not as easily seen is the degradation to the health and diversity of our freshwater systems by those fluorides. Metal corrosiveness, they all to some degree are corrosive to metals. So right now, let me just show the elephant in the room to the exit here. None of these chlorides are okay for pets, all right? Magnesium and potassium are a little less toxic, but they still cause dryness or excessive dryness, cracking, even burns on paw pads and with repeated or prolonged exposure to stepping on them. And if ingested, they can cause GI upset or even organ problems. So the best I can say is just don't over apply and be sure to wipe off their paws to remove that residual ice melt to help reduce the paw irritation, and then help reduce the likelihood of them licking it off to get rid of it and ingesting it. And I will later be talking about some non-chlorides that are less irritating on the paws and less toxic, but still they should not be ingested. In regards to the chlorides accumulating in the environment, at the moment, there is no economical way to remove those chlorides from our freshwater environment. So if there are any entrepreneurs out there, this could be your claim to fame if you can figure out an economically scalable solution for that. Okay, so chlorides in our freshwater, they wreak havoc for the circle of life, and we are a part of that circle of life. And I'm going to scale this to Wisconsin since I happen to be in Wisconsin. Wisconsin uses an average of 56 gallons of fresh water per day per person from public and private supplies. So there are 5.9 Wisconsin residents, and doing that math, you then come out with 330.4 million gallons of fresh water used per day. And about 2/3 of Wisconsinites use groundwater as their drinking water source. And that's really important to acknowledge as to why we're trying to change our best snow and ice management practices to eliminate the amount of chloride runoff that's getting in our freshwater systems. Another interesting thing here is 17% of Wisconsin is covered by fresh water. And you'll see in this chart of the top 10 states with the most water by area, Wisconsin way beats out Minnesota. Woo! But nonetheless, Minnesota is really making a dent in reducing their chloride usage and still creating safe winter environments and being profitable. Wisconsin does have a ways to go, but I do believe that we are on the right path. So now let's take a look at where in the earth these chlorides come from and how that scales into what you pay for. So sodium chloride, also referred to as rock salt, is mined from deep underground. And in the United States, the deposits were found by mistake when they were drilling for valuable minerals and oil. And one of the first mines to be found was the Hutchinson salt mine, and that was discovered in 1887. And the sodium chloride at that time was used mostly for food and chemical compounds. And this rock salt deposit is huge, and it's from the ancient Permian Sea over 275 million years ago. I realize this is just a blip in time compared to what we're seeing in the James Webb Space Telescope now, but nonetheless, I feel it's worthy of noticing. Anyway, and then within just a few years from the Hutchinson mine being established, numerous other companies started drilling into that same ancient rock salt deposit. So I can just imagine everyone now must be asking, so when did we start using rock salt to melt ice? Well, that was 1938 was the dawn of rock salt for use as an ice melter in New Hampshire. The location and timing makes sense if you consider when gas-powered cars were introduced in America. That was about 1893 by the Duryea brothers of Springfield, Massachusetts. And then you have the invention of factory lines that made cars available to the masses by the late 1890s. And we all know car tires do not have great traction on ice. So pictured here is the Kannapolis, Kansas mine, which is drilling in that same big Hutchinson deposit. And the extraction process is much like coal mining in that it requires a lot of underground large equipment work. And yet rock salt is our least expensive ice melter. The other chlorides require more technical processing that ratchets up the price. For instance, calcium and magnesium chlorides come to the surface in liquid form. They have to be dried and processed for the granular shape that we're familiar with in our ice melters. And this picture shows, for instance, how these liquids are processed. These are expansive evaporation ponds that produce the chlorides from the Great Salt Lake in Utah. So you can just imagine there are a lot of touch points and handling that increase the cost. Other factors relating to price is that magnesium and potassium sources are not as abundant as sodium and calcium, and potassium is even less abundant, and most of it is sourced from Asia. So if you just think of here, our freight costs, our labor shortages, and other things, it's all complicated by being further abroad. So logically, price is relative to the cost of mining, processing, and bringing to market. So now that we know how ice melt chlorides are produced, what their working temperatures are, and some of their distinctions are, how do we choose which ones to use? We need to know what's in the bag. And as most of you know, it's not as simple as it sounds. There are a lot of blended ice melt products, both granular and liquid. They all have SD sheets, that's safety data sheets. And these sheets have a section there that tells you what the ingredients are. But the manufacturers are not required to provide the exact amounts of those ingredients, or even really what those ingredients are, because they're not deemed harmful to humans. So you need to use a discerning eye before making your pre-purchase, and remember this chart and then the actual sourcing of these compounds that I just told you about. And also realize that your vendor will not have the actual ingredient amounts either. So the better ones will help you cut through the smoke and mirrors and land on choices best suited for your applications. And for this SD sheet that we have up here right now, for this particular product, let's look at this. Their selling point here is that it is effective to minus 20 degrees, and it's really expensive. So let's take a look at this. So we see, okay, rock salt, sodium chloride, that's mostly what's in the bag, 92 to 98%, all right? And then we have a chloride solution with proprietary added, less than 2%, a colorant, less than 1%. Okay, this colorant, we can just check that off the list. Those are usually just water-based colorants that help you see where you put down the product. And it's saying that it's effective to minus 20. So we have mostly sodium chloride, and we know that that is effective to 15 degrees, all right? So something's in here. Okay, minus 20, that's the calcium. All right, so my best guess is that this rock salt is sprayed with a calcium chloride solution, and then it's all mixed up. And then there's some kind of proprietary additive, which my other guess, it's a good educated guess, is that it's a anti-caking chemical to keep the rock salt from caking up. And I would imagine that's probably a YPS or a yellow cruciate. So that's mixed in with that solution, and then they spray it on the rock salt and mix it all up. And my next best guess is that this company or manufacturer probably sells this product bulk, and then they bag it to sell it in bags as well. Considering how much rock salt is in there and what this additive solution at that amount is, I can see that it would be relatively inexpensive. So it's still going to work at minus 20 degrees. You're going to see it work at that low temperature. The thing to keep in mind, though, with so little of that calcium in there, it's not going to work for a really long time. So it's going to dilute out. So what you're going to have to keep in mind then is that if you're putting it down at a low temperature, you just want to make sure in the event or in that day, you're going to get some heat coming in from some sunlight to activate that sodium chloride, to get that to start working and keep that product working for you in your operations. Let's take a look at another one. This one, let's see here. Okay, so this one's selling points is that it's effective to minus 22, it's anti-corrosive, and it's environmentally friendly. Okay, well, let's look at it. Again, we have mostly sodium chloride rock salt in the bag. Then it has magnesium chloride and potassium chloride. And then it has the CMA, calcium magnesium acetate. That's a non-chloride, and I'll get to that in just a second here. But the magnesium chloride, that's the one that'll get it down, working down to that lower temperature. And then this potassium chloride, well, potassium and magnesium, we saw earlier that those are less toxic than the sodium and calcium, so those could be considered environmentally friendly. That's typically how that goes. And then you have the calcium magnesium acetate, which is the anti-corrosive one. That was developed because it is anti-corrosive. And it's also very expensive. And as I said before, the magnesium and potassium, those are expensive as well, just because there's not as much of it. It's a little bit harder to get those out of production. So you've got about, okay, so it says 0.01% to 5%, anywhere in this bag. And considering these price points that I just let you know about, yeah, it could be more expensive. And this bag is one of the more expensive ice melt bags on the market. But just like that other one we looked at, with these smaller amounts in here, sorry, these guys, it's going to be short-lived. So you really want to make sure you know what's going to happen with that winter event. When you put it down, it's going to start to work quickly, but then you're going to need that sun coming in to activate that rock salt and keep it working for you. And the thing about CMA or calcium magnesium acetate, that's what it looks like. This is what CMA looks like. Interestingly enough, it was developed in the 1970s when the chloride veil was lifted and we recognized all the problems that they were causing. The Federal Highway Administration drove the mainstream acceptance for the use of CMA. And laboratory studies have shown that CMA, when mixed with sodium chloride at a minimum 20% by weight, inhibits salt's naturally corrosive properties to exposed steel. And the more the CMA in the blend, the better the corrosion and the concrete's falling protection. And this is reported by Peters Chemical Company. And the primary manufacturer of CMA, which is Cryotech, they even have their own blend of sodium chloride and CMA. And that's at a rate of 40% CMA to 60% rock salt. So that's just a reference point for you as you're looking, and you might see the CMA and some other ice blends and what you're looking at in this amount that they've got in there, to see just really how viable that could work at being anti-corrosive, for instance.
Stacey, can I ask you a question?
You bet.
On your last slide, and really both of your last slides, I just want to point this out and make sure I'm understanding this. the selling points are how the manufacturer is promoting their product, right?
Yep. Yes.
So what kind of we're seeing when we really take a look at these labels is both of these products are primarily composed of sodium chloride, right?
Yep.
And that's what allows prices to stay lower, but then they're claiming that they're effective down to those negative temperatures when we know that sodium chloride is not. So they put a little bit of something in that is effective at those colder temperatures and then say that the product as a whole is. And then the second one, to call it environmentally friendly when it's primarily composed of sodium chloride, magnesium chloride, potassium chloride, all those are chlorides, right? So seems like if the way the manufacturers see this is if they put a little bit of something good in, that they can claim this. It's kind of like you I don't know, you eat at McDonald's, but then you have a couple leaves of lettuce afterwards or something. It was a good day for the diet. I don't know.
Yeah, kind of. That's a funny analogy, but yeah, and a lot of them are this way, and I can, like I said, with the magnesium and potassium, they're just they're selling on the realm that they're less toxic, but still we know that in essence they still accumulate in the environment. So it's still going to be there in the environment as far as that goes. And then with that CMA in there, that definitely is worthy of ratcheting up the price, but it's not going to have any long-lasting effect of being anti-corrosive, especially when that sodium chloride keeps working in there. So yeah, that's pretty much what I'm pointing out. So you want to do like I said, just try and do your due diligence in reading these ST sheets and just anticipate what those storm events are going to be. So you're going to know that if it's going to stay really cold, you need to use a product or even a brine that's going to be able to maintain working at those colder temperatures. And since we just started talking about the non-chlorides, let's keep moving with this, and let's focus on the organics. So when we talk organics, think of beets, think of beer brewing mash, cheese brine, as well as others like molasses or corn syrup. And remember that the organics, they do biodegrade in the environment, but they take a lot of oxygen to biodegrade. And they don't actually melt snow, but when they're combined with a chloride, solid or liquid, they do help to lower the freezing point of the chloride that it's paired with. They reduce the corrosiveness of the brine, and they can also improve the friction or adherence to the pavement, which provides that residual melting strength. And what you want to keep in mind as far as that friction adherence goes, and this is also referred to as viscosity, is that it'll differ from byproduct to byproduct. And it could be that you got to watch out that if it's too thick, it could stick to people's shoes and they're going to track it into their cars, buildings, homes. If it's too thin, and this has been reported with some of the beet juices, it could induce mold and even a foul smell. So you just need to be aware that there's still things that you need to look out for, even with these organics. And typically, these are sprayed onto the granules by before they get put into the bag, or they're sprayed at the hopper before they're applied, and they're also mixed in with brine for a ready-to-use product. But these organic additives are most often referred to on the SD sheets as a proprietary additive. And this is really interesting. In Wisconsin, just a little bit of trivia here. We made national news in 2013 when Milwaukee tried out cheese brine with reported success, actually. They were mixing cheese brine at 8 gallons per ton of rock salts. And this makes complete sustainable sense since we're the cheese capital of the world. Well, at least I think we were in 2013. I don't know if we still are right now, but still, it makes sense. We still eat a lot of cheese here. Okay, so the other most used non-chloride ice melters are acetates and formates. Now, these are highly manufactured in labs and therefore they're at a higher end of the cost spectrum. They are made from acetic acid and formic acid. And unlike chlorides, they are not very corrosive to steel. However, they do react with and corrode galvanized steel and zinc. So for this reason, all these products are going to have corrosion inhibitor additives. Think back to what we just talked about, the organics. And these formates and acetates require less oxygen to biodegrade than the organics. So they're made in liquid form as well as in solid form. The better known acetate ice melters are like the one we just talked about, CMA. And CMA is both solid and liquid. Then you have a sodium acetate, this is one, NAC. There's a potassium acetate that's a liquid, that's called CF7. And then in the formate family, you've got a sodium formate. This is one of them, 0 ground. And then you also have a potassium formate in liquid form, and you've got KF50 plus or entry. So neither acetate nor formate-based deicers are meant to be used on heavy packed ice or snow. You must physically clear the accumulation before applying to get the best use of your money and of the product. And a few differentiators between the formates and acetates. Formates require much less oxygen to biodegrade, and they degrade within the first 2 inches of soil, and that's from acetates. And then formates also get to work a little bit faster, and they're a little less corrosive than the acetates. Acetates, they work a little bit longer, and they are marginally less expensive than the formates. So to summarize what you just heard in terms of chlorides versus non-chlorides, the cost of chlorides is less expensive. They all have a potential impact on the environment. Chlorides accumulate over time, posing risks to human health, water quality, aquatic flora and fauna, as well as the environment directly adjacent to the application site. And then we have the non-chlorides. While they don't accumulate, they do consume a lot of oxygen as they're breaking down in the land of water, and that's taking the oxygen away from the flora and fauna that need it to survive. So we're not going to use any of these deicers, but we can be smarter in our use of them. And I was really surprised and happy to read in the September 2022 issue of Snow Magazine that the US Army is working on a zero carbon, cost-effective process to make liquid potassium formate deicer that can be readily deployed at all of their bases around the world. And in conjunction to this, their goal is for this production model to be economically scaled and made available for municipal and commercial use, with the intention that it can take the place of chloride-based deicers, alleviating the impact on equipment, infrastructure, and the environment. So if you think as far as municipalities go, think of all the roads, highways, bridges that our tax dollars pay for. So the theme that is developing here is that no one deicer is going to do it for you for everything. So you really want to stock a variety based on your site needs, such as the anticipated range of temperatures, and you want to take into consideration the shadows that the buildings are created in the sites that you're managing. You need to take into consideration the chloride damage potential to infrastructure. Think of the metal doors, carpets at entrances, stair railings, bridges, decorative paving. And then also think of the chloride damage potential to the environmental surroundings. Think of expensive landscaping, natural waterways, and proximity to storm drains. If this is sounding expensive, the good news is most everyone is over applying. So we can cut costs by properly scaling usage. And how do we do that? We use equipment that can be reliably calibrated for your product of choice. And we need to make records for each snow event. That is to record the application rate, which product we were using, which machine we used, who was applying, record the weather, and then post-event, review, analyze, and adjust if or where needed. So I get it that for most, this is a jump out of business as usual, which means carving out time to make this the new norm. And no one perfects this right out of the gate. Just keep the end game in sight and working towards it. You will get there and it will become your business as usual. But let's take a deeper look at the calibration component of this. So what does calibration refer to? Well, it's the equipment that has reliable adjustments to apply relatively the same amount of ice melt in a predetermined area. I can speak about push spreader equipment used with granule or the solid ice melt. For these spreaders, we typically talk in terms of pounds per 1,000 square feet. And pictured here is a 36-inch wide drop spreader. What sets this one apart is the gate opening mechanism. There are two tension knob screws to these things right here that can finally adjust that gate opening. And you've got setting numbers, a little bit hard to tell, but these are numbers, there's notches right there. And then you've got this pointer that tells you exactly what gate opening that you're at. And then the open and close lever is connected with a metal tube, this right here, instead of a chain. So it's much more durable. And then there are also oil and grease locations for maintenance and mechanical longevity, which also makes complete sense, especially if you're going to invest in a piece of equipment like this. Another type of push spreader is a broadcast spreader, and these are a little bit more difficult to calibrate. But this one pictured, we have found that is really pretty good, and it's because of this reliable dual calibration mechanism. It's the first of which is this yellow variable deflector. It's one piece, and it's made of hard plastic. Most others are three pieces, they're really thin, and they're not connected. So in the areas where they're not connected, you'll just have your ice melt just flowing out there, and you're just kind of like sand running through your hand. You're kind of wasting that. And then the other thing is this deflector can be changed so that your spread width pattern is 3 feet, 6 feet, or 12 feet. And all you have to do is move it out and then move it up or down and lock it back into this metal mechanism right here. It's really simple and it's really secure. The other thing on this is the gate control lever by the handle. It has a large slide area to accommodate kind of fine tuning of the gate opening. And this is the opening here and this kind of little half moon thing. This is what closes and opens when you're moving this lever. And then there's also, I should explain too, this little piece right here, this constantly spins while you're pushing the machine or the piece of equipment, the push spreader, so that it's breaking up the clumps of ice melt in there. So you've got an even flow pattern. And then there's also to this particular unit, there's also a large knob that helps to, it's a large tension knob that you can lock in the desired opening. And what's good about this is that most hands are going to be gloved using this, or they're going to be big hands. And it's good to have larger pieces to be able to grasp. It's much more efficient than trying to get a wrench to, trying to hold and work these little components here. So they make a difference. But beyond looking at your equipment to see if it has the mechanisms worthy of calibration, you really need to put them through the test. And that's the process of calibration. So you want to test your spreaders before the season begins to determine, one, if they can be reliably calibrated, and if so, you want to find the optimal gate opening for each of the products that you're going to use with that spreader. So start by determining how much area you need for your trial. And again, think in terms of pounds per 1,000 square feet, which is used most often for sidewalks and parking lots. And we use this chart. It's kind of a cheat sheet for spreaders that are 3 foot, 6 foot, and 12 foot wide. And if we're using the 3 foot wide drop spreader that we just looked at, and we know that we can clear an area that's 3 feet wide by 83 feet long, we're looking here in our chart, then we know that we have to do 4 passes. And a pass is you go out once, back 2, out 3, back 4. That's 4 passes. Okay, so now that you know what your area is, you need a chart to record your results. This is the chart that we use. It is necessary for future referral, so we know what we did, what spreader we're using, what that trial area is. Then we have a space here that lets us put in here how much we want to put down, how many pounds we want to put down per 1,000 square feet. And then we also have space to put in the weight of our collection bucket. So what we use, just down and dirty 5-gallon bucket. You just want to make sure, it doesn't matter what it looks like, just make sure the inside is clean. And this is going to be your receptacle for your ice melt that you're going to weigh on your scale. This is a portable scale that we use. It's battery powered, digital. We've taken it all over to our stores. It's very good. It's real, and I got it off of Amazon for like $40, and it's proven its worth for sure. So that's all you need. So you want to first set your gate opening. Choose a gate opening. Got to start somewhere, right? So let's say here we're starting with a gate opening of 7. All right, we put in 20 pounds of whatever ice melt we're using, and for this particular spreader, it's 3 feet wide. So you need to make sure you're putting in enough product to have good amount of pressure going into that gate open, the gate opening, so that it mimics what's really going to be in there, and you've got a good flow pattern. This unit technically takes 100 to, I think, 150 pounds. So 20 pounds was a good pressure in there to get an accurate amount to flow out. So you do your 4 passes, then you dump what's left in your hopper onto a tarp, dump what's on that tarp back into your bucket, weigh your bucket, subtract what that weight is of the bucket, you come up with your weight of the remaining material, subtract these 2, and you get what your application rate was. So what you want to do then from there is do this for a few more of those gate openings. And especially on this machine or this piece of equipment that has quite a range of gate openings, you'll probably do more than 4. You'll probably do maybe 6 or 7. And when you land on, you want to go, after you do your gate openings, then you're going to be able to tell from this final countdown here if this is really giving you an accurate calibration. You want to go back to the gate opening that got you closest to whatever you chose to be your pounds per 1,000 square feet, and rerun that and just make sure that you're getting close. It doesn't have to be exact, but be close to what it was. And then you can continue to do that with your other spreaders that you're going to be using for the season. So just as important to using calibrated equipment, you need to record what your crews did with it and conduct a post-event roundtable with the crews. So you want to be recording the date, the location, the equipment, the operator, the site conditions, which includes the weather conditions, what the product was that was applied and at what rate, any observations. And this kind of tracking is going to help you plan for the next storm. It's going to help you bid for that next project, keep morale high, costs down, and your margins up. So let's do this. Let's keep it fresh and keep it safe. And that's pretty much all I got.
Awesome. Thank you, Stacey.
Yeah.
If you want to end the screen share, we can both pop up here for the Q&A.
Okay.
We did have a couple questions that came in. One immediately on the chat, and then another one over email, and hopefully people can send some more questions our way here.
Yeah.
So the first question was, can we get a list of environmentally preferred de-icers with application rates to share with, and this person said municipalities. Could you identify sources for these options as well?
Yeah.
So there's a lot in there.
that was, but it's completely understandable. And it's a tough one to give, especially the application rates. It's really tough to be able to give you set application rates, because it's going to change per piece of equipment that you're using. All of the most of the manufacturers will give you an application rate on the product that they give you. And again, where that is difficult is because that rate is going to change at each of the events that you have based on the humidity in the air, what that pavement temperature is. That pavement temperature is huge. So you want to know what that is relative to what that air is. Is it rain that's going to be coming in? So this is what I was saying before, is that it requires quite a bit more thought than what our traditional model is for applying the ice melt. And that's why I'm saying to track this, so you can get a better judgment on where you need to be with those ice melts. For sure, we could give you application rates and the better products that are, I think he was looking for products that are better for like non-chlorides, better for the environment and so forth. But you gotta know that there's still work to be done with it on your end relative to where you're putting it down.
Yeah. So
Sorry.
I think you brought up that there's a lot. There's a lot in that there aren't I want to say like truths here, right? Like there's a lot of variability to consider. I did put into the chat though a link to the application rate chart that we have on the Saltwise webpage that is geared towards parking lots and sidewalks.
Yeah.
I'm also going to put in another link in the chat. We had a conversation with Andy Bill, who's a researcher at the UW TOPS lab, the traffic lab, and she does work for Clear Roads, which is a consortium of state DOTs. So they do a lot of research trying to understand rates. And Andy presented this last summer a webinar on application rates for roads. These are liquid application rates, so brine rates. But I'll also put in just the Clear Roads website. I mean, they've got a ton of research there. So if that would be a great place to start, if people want help trying to like sort through that and understanding what makes sense for their municipality, happy to support that. But I'll put some links in there to kind of get a head start. And then, yeah, I think Stacey did a great job of just these big concepts of chlorides, persist in the environment, right? They're not environmentally friendly. And just putting a little bit of something that isn't a chloride in doesn't, negate the fact that you've got 90% of what you've got is sodium chloride in your bag. And then, so there was also a question that came in via email kind of about that. Fred had noted that the EPA has a safer choice label. And I don't know if you can speak to that, Stacey, because the products in that safer choice, or that have that safer choice label, are chlorides. So do you know kind of how they were able to be labeled safer choice? Because
I just wrote this down. I'm going to check that out. I'm completely unfamiliar with that.
yeah, because I'm familiar with the Green Seal certification, which Entry, right, the one product you mentioned, is the only product right now that is Green Seal certified as a chloride-free de-icer, right?
Right, exactly. Yep.
Yeah, but KF50 that Reinders sells is also a chloride-free
Yes.
de-icer. But you guys, sounds like it's a process to go through and get that certification, right? So
yeah, it is. It's an expensive process. So I would my recommendation with that is, for sure, anyone who is working in a lead project or environment, they should for sure use Entry, because that goes towards lead version 4.
mhm.
So your property can certainly benefit from that.
Mhm. All right, so Steve put in here a comment. It looks like a largely unrecognized unintentional impact from organic de-icers is the formation of prolific biofilms in receiving streams. So I think, speaking to the idea that you shared, I guess you talked more about the fact that oxygen levels are going down, right, as these products are being degraded, but the idea that oxygen levels are going down because little microbes and things are eating, right, those sugars. And I, like, from a chemistry perspective, I would also include acetates and formates in your category of organics, because technically they're organic, they're carbon based, right? So they're food for those microbes.
Yeah.
So Steve also asked, any chance you've seen more work done on this for a variety of organic de-icers?
I'm sorry, wait, what was it?
Yeah, I guess maybe Steve, if you want to clarify in there. So Steve had said that one impact from organic de-icers is the formation of these biofilms. So bio, like living films, so tiny little films of organisms, right? In our streams. And he's wondering if we've seen any work done on this for different organic de-icers. So maybe he's asking about environmental impacts of different organics.
I no.
Okay. So no, Steve, if you want to ask any more clarification or ask for more clarification on that, Steve, if I misinterpreted your question, feel free to chime back in. Otherwise, happy to kind of confirm with you afterwards too. Steve is a researcher in the Madison area, actually, even though we've not met in person, but he he helped to put this problem on the map with some of the early work with USGS, looking at chloride concentrations in Milwaukee streams over 10 years ago now.
Cool.
And he said that's what he was asking about. So
okay.
All right. Well, Richard has said, are there any specific suppliers locally for CMA in the Milwaukee area? So if people wanted that CMA, that chloride-free de-icer in Milwaukee, where would you send them?
I know there's a few of us around. We do have CMA.
So Reinders in the Milwaukee area. Where is your location, closest location?
We have locations. Our biggest warehouse is in our corporate location in Sussex. Then we also have a Waukesha location. We've got Madison. We've got one in Stevens Point, one in Appleton. We have one down in Bristol.
Okay, but for someone in Milwaukee, the closest would probably be the Waukesha.
Yeah, Waukesha or Sussex.
Or Sussex, I guess.
Yep.
Yeah.
So those cryotech products we've got.
Okay.
And
so you could probably go to a variety of vendors, but of course, Stacey would be happy for you to come to Reinders to get your CMA.
Exactly. I'm sure that the other larger distributors of these kinds of products would probably have it.
And let's see. We get another question. For protecting paws, you suggested to wipe them down. This person's asking just a dry towel.
Even just a dry towel would be fine.
Mhm.
When they come inside, if you take them to the office, or if you're like me working from home, just wipe off those pads. Try and, something you can use water, but then you got to dry it again. And I think if you just try and wipe that off, that will definitely be very helpful for them.
Great. Yeah, and I do have, I'll try to find it here, an archives webinar with a veterinarian talking about impacts of salt on pets, and I'll put that in the chat if you want to check out that resource as well. Okay. Awesome. Well, let's give people a moment, Stacey, since we're a little bit ahead of them.
Okay.
I don't see any other questions coming in an email, but this was great. I really appreciated I'm a nerd about this topic, right? So I appreciated your research and homework, bringing up photos from the salt mine and a little bit of a history lesson, and just kind of putting into context why some of these chlorides are more expensive than others, right? It's the process of how we're getting them.
I think it's really interesting. I think it's really good to know where the stuff comes from that we use.
Mm-hmm.
Not just our ice melt, but in general. I think it's really good to understand where these things are sourced from.
Mm-hmm. And that, the factors then that influence the price point, right? Because even in central Wisconsin, you pay more for salt in Wausau, for instance, than you are if you're in Milwaukee, really close to the port, right? Because of those transport costs. Yeah,
exactly.
Mm-hmm. So, all right, well, those are the questions that have come in. So I think, we're good there. Steve, if you're still on, would be happy to chat with you more about biofilms at some point. Okay, we did have another question here coming in from Richard again. Are there any local suppliers in the Milwaukee area for that liquid form of CMA?
Yes. Actually, it's north. It's a little bit north of the metro Milwaukee area. Read something. I have to look that up. I don't have it.
So Richard, if you want to email me, I'll just put my email in there, and I can be the go-between here. So email me and I'll get you in touch with Stacey. I would also say, if you want a liquid product that is chloride free, that the KF50, right, Stacey, that you guys sell, would be another alternative to CMA, right? Both of them being chloride free liquids.
Yep, absolutely. But regardless, I'll get that company name, and I will, Allison, I'll get it to you so you can turn that around.
Okay, sounds good. Someone from the Indiana Lakes Management Society said this is a great information for commercial applications. What about a talk like this for residential? So
a group that I sit on the executive committee for, the Waukesha County Green Team. I'm actually doing just that for them, for their executive team next month. So it'll be really similar to this, but it'll be drilled into more of a residential.
And are you giving that, Stacey?
Yep, I'm doing that.
Okay, well, maybe we just line you up, with that talk later. I was thinking about that. I was thinking about priming you and letting you know that we have a mix of folks that join our webinars. So some people are looking more for just that, advice around the home, as well as people who are working in the commercial world.
Yeah.
But yeah, I think we can definitely make that happen. Whoever we've got there from Indiana Lakes. And in the meantime, I would say that going to our website, going to the Take Action, and then winter salting would have good information kind of in print.
So. Yeah, your website's awesome. Very good.
Thanks. All right. Well, thank you so much, everybody, for joining in. Thank you, Stacey.
Yeah, thanks for inviting me, Allison. I really appreciate it.
Well, all right. Well, you take care. Stay warm.
Okay. See you guys.
Bye-bye.